So with lead bromide, I'm just going to draw out the electrodes, and then I'm going to draw out what solution we have. So we have lead to bromide, and with our lead to bromide, when we melt it, we have ions forming. So at our positive end, we have our Br minus ions forming, and at our positive end, we have our Pb2 plus ions forming, and we know that because of the Roman numerals 2 plus. So you need to know how to form ionic equations from this. And when you're writing ionic equations, I'll always say write the ion first, and then put an arrow showing that it goes to its atom. So this is always what happens in ionic equations. The ion always becomes the atom, and we say that the ion has been discharged. And discharge just means that it loses its charge. Dis meaning opposite, and charge. So all ions are discharged when they touch the electrode. So after lead has discharged, it becomes an atom. At the positive end, it's our Br minus that has been discharged and forms a Br molecule. That's because it's diatomic. Now you need to know that all group 7 elements are diatomic, but then also your hydrogen, nitrogen, and oxygen, they're also diatomic as well. So they always form molecules when they're discharged at that end. So once they're discharged, I would say leave some space here to put the electrons before. Okay, and then now you need to fill in the electrons. So with your Pb2 plus ion, it's actually gained 2 electrons to form your Pb atom, whilst your Br minus ion has actually lost an electron to form a Br2 molecule. So because it's lost an electron, we put the electron on the opposite side of the equation. And if you flip this, if per se you flip this equation will still work. So if you have a Br molecule and you added an electron, it will become an ion, a negative ion. So that's how you know that you put the electron on the opposite side. Once you've done that, you need to balance this one because you've got a molecule here, so you need to put 2's in front, and that is your ionic equation done. The only other thing that you need to know how to do is to figure out which one's oxidation and which one's reduction, and you use oil rig for that. So oil rig, oxidation is loss. Here we've gained electrons. So because we've gained electrons, this is reduction. So reduction is happening here. This one, we've lost electrons, and that means it's oxidation. Oxidation has happened there. Let's try another one. We'll try sodium chloride. So with sodium chloride, this one's slightly more tricky because we have an aqueous solution. So again, I'll draw out the electrodes. We have positive, we have negative, we have our solution of sodium chloride. Now we have our positive electrode at this side. Now we have actually 4 ions in sodium chloride solution. We have our OH minus ions from the water, and we have our hydrogen ions from the water. Then from sodium chloride, we have our chloride ions from the sodium chloride and our sodium ions. Now here, only one ion can be discharged at the electrode. The ion which wins out, there's a rule to know which ion wins out. So at the negative end, it's always group 7 that wins. At the positive electrode, always group 7. If there's no group 7, then it's your hydroxide. And if it's your hydroxide, you're going to get oxygen released, and we'll talk about that. We'll do the equation for that next. You just have to learn that equation. For your positive end, your negative end, sorry, it's the least reactive metal, it's the least reactive element that wins out. And that's pretty much always hydrogen, unless you've got copper, silver, or gold, or anything like that there, but it is pretty much hydrogen always. So here you have hydrogen will win out, and then you have chlorine will win out here because it's group 7. So if these two win out, they're going to be removed from solution, so they'll be discharged. Here you have the first one, we have hydrogen, that's discharged because the charge, we're losing charge, and it forms H2 because it's a diatomic molecule. Now it's going to gain an electron, or two electrons to form H2, and then balancing it, we get that. Now with our chlorine molecule now, chlorine actually becomes discharged to form a chlorine molecule, and that loses electrons. So we put the electrons on this side. So because it loses electrons, we put the electrons on that side, and again, we need to balance it. So exactly the same as above, this one's being reduced because it's gained electrons. Then this one's being oxidized because it's lost electrons. Very easy. Now the only thing you now need to know, one other thing you need to know here when talking about aqueous solutions is what solution is left behind. Here it's sodium, we have our hydroxide and we have sodium, so it's actually sodium hydroxide solution is left behind. Now this reaction, just on the side topic, is very important because here we get hydrogen and we get chlorine. Hydrogen is used for rocket fuel, so it's a very important rocket fuel and other things. Rocket fuel, and chlorine is used to disinfect swimming pools. It's that horrible smell that you get. So it's used as a disinfectant, and then sodium hydroxide, which is left over, is used as bleach. So this is actually a really useful electrolysis reaction. Okay. The last one we'll do, and then I'll leave you guys to it, is we'll do copper sulfate. No, sorry, we'll do sulfuric acid. We'll do HOSO4. We're going to do exactly what we did. We have our electrodes, and these are inert, so they don't take part in the reaction. That's normally carbon or platinum. And we are going to have, because it's an aqueous solution, again, we're going to have 2 ions at each electrode, and there's going to be a battle. And you need to know which one wins out at that battle. So at your positive end, you're going to have your hydroxide from the water, the other side hydrogen, and then SO4 2 minus. Sorry, that's minus. Now you should know that out of your head because it's a golden 5 molecule, and this is one of the reasons why you do need to know the golden 5 because it comes up in so many different places in your chemistry. And then the other one here is hydrogen. So actually you've just got hydrogen, you've just got 3. Okay. So here we know our hydrogen is going to win out. Now you already know the half equation for this because we've just done it 2 times, and we know that. And then your other one here, we've got to find out which one wins out. We've got hydroxide, we've got sulfate ions battling at the electrode. So the one that wins out is going to be our hydroxide because there's no group 7 here. Okay. So hydroxide wins out. You need to know this equation out of your head because there's not really any way of like figuring it out really. So hydrogen, you need to know that hydroxide forms water and oxygen plus 4 electrons. You just need to know that, and to balance it out, you have to have 4 hydroxides for this to happen. You literally just need to know that equation. There's no way of getting around it. So here, this one's gained electrons. So it is reduction, it's oil rig. So this is reduction, this is oxidation because it's lost electrons. And then our solution left over is going to be sulfuric acid because there's still some hydrogen left, and those hydrogen, sorry, there's still some hydrogen left. Sorry, there's water formed here, so you are just going to have sulfuric acid left over here. Now, if you had a different one like copper sulfate, it will be exactly the same. You'll have your hydroxide, you'll have your sulfuric acid, you'll have your copper 2 plus over here, you'll have your hydrogen. But copper 2 plus, that will win out at the electrode. So instead of your hydrogen, you'll have copper 2 plus 2 electrons, reacts to form your copper atom. And then your hydroxide, that's discharged, this is discharged, so you'll have sulfuric acid left behind. And all acids are always aqueous. Okay. Now, if you look back at this top equation here, your hydrogen and your hydroxide, you can see that for every, if you double this, let's say we double this, we have 2 hydrogens, we have 4 electrons, and then 2 hydrogens here. You can see that for every 4 electrons lost or gained or going around the circuit, we have 2 hydrogens produced and 1 oxygen produced. So this just shows us that there's actually double the amount of hydrogen in water. So this actually proves to us that H2O, there are 2 hydrogens for every oxygen molecule. Guys, are there any questions there with forming ionic equations? Any questions? This video, I'm going to try and send you this video so you can watch it again if you need. Wait.